I'm Mark Anderson, account manager with SGI. I'm with the commercial account sector. I'm based here in Atlanta for the Southeast. And we have a few folks here with us that I want to introduce. Mike Moretti is in the back, our East Region Director of Sales. And then David Hackett with Cloudera is also there with us. Of course, over here to my left, Chris Devaney with Cloudera. We also have David Sundstrom. There you are, David, with SGI, who's our product manager. And also our friends at Ardera, who's a SGI partner here in the Southeast. So Steve Lamsey is here with their team. So we'd like to welcome all of them as well. So the format for today is what we're going to have is Chris is going to talk and give you a short presentation on Cloudera and their place in the market as a leader in the Hadoop environment. And then David is going to be speaking as well. And then we're going to allow for about 20 or 25 minutes as well for some question and answer time. And then if we could, since we are recording today, if David and Chris, if you could just, when you hear the question, just repeat it into the mic so that way it's there for the recording. So with that, we'll go ahead and get started. Thanks, Chris.
Yeah, sure. Good evening, everyone. My name is Chris Devaney. And a little bit on my background, started with electronic data systems, date myself a little bit back in the Perot days, moved into relational databases, worked for Informix. There was this new thing that seemed interesting called OLAP. I moved in, was an early employee with MicroStrategy in the OLAP world. I've been in performance management, balanced scorecarding. I started a company and that was acquired, and I was looking for, what's the next generation, what's the next platform, what's the next interesting thing in technology. And one of the things that I'd seen throughout my whole career was always butting up against the upper end. Always too much data, always begging for a faster processor when the database world, just anything to go faster. And what we want to talk about tonight is not only just how do you get the data, why is all this data being created, but how do you profit from it? That's the hard part. I mean, getting it is one thing, but there's so much of it. How do you get through that data, and how are companies profiting from the information that's stored in that? So I'm going to talk about solving the big data challenges, and I say Hadoop Plus because Hadoop is one component of an ecosystem that forms the platform for managing big data. Just a show of hands. Who has not heard of Hadoop before? Okay, so I'll give some background on that because obviously it's kind of this quirky name. What does it do? But it's a very interesting platform, and we'll talk about that in just a little bit. And I think this was mentioned before, but there's just been an explosion in the amount of data that's being generated. Prior to 5, 6, 7 years ago, there was a governor on it, a restrictor, which was it was human generated. So we were taking reservations and we were keying in information as fast as we could. But what's happening now is machines are generating it, right? And machines are generating very valuable information about your customers, your buying patterns, your all these different attributes about that. But there's no ability to ingest that because it's being generated so fast. Right? The other thing is it creates a different format of data. It's not just first name, last name, address, phone number. It's unstructured data. Weblogs coming in, videos coming in, formats in the future that we haven't even defined yet. So it's hard to kind of build technology around that. So if you look at it, we have all these different devices that are producing tons of information. But if you look at historical and traditional platforms, they are down in the lower spectrum here. They're linear scalability. They can store those transactions, but they really were never engineered to store unstructured data in the volume that it's being produced. So a lot of companies, as I mentioned, are hitting that upper end. There's a company today that wouldn't be in existence if they didn't solve the big data problem. Okay? And that company's Google. Right? They knew the day they started that there was no technology that could ingest the volume of data that they were going to be generating day one. You couldn't stack enough machines next to each other to do that and put what we'll call a traditional database or some sort of technology to do that. So what they did was they said, well, we need to develop a big data platform, right? So rather than put it in a database, which requires structure, because they knew they were going to have unstructured data, they said, well, let's build it on the premise of a file system. So you can store, as you know on your computers, you can store pictures and text and all kinds of things on a file system very easily, very fast. And if you want to run a query against that or a search, it's very easy to do, right? You can say, show me everything that has the name Chris in it, and it will bring back documents and pictures and everything else across that file system. So they said, a file system is a good way to do it. So they developed something called GFS, which is a distributed file system that makes many machines appear as one. So it's kind of the reverse of a virtual, right? So you take tons of machines, make it look like one. Okay? But once you get all that data there, you want to do something with it. So they built a data processing engine on top of that. And that data processing engine was called MapReduce. Okay? It gave you the ability to ingest the data, transform the data, run analytics on that data. Okay? And then they said, you know, there is kind of some neat things about a database that we want. So they also built something called Bigtable. Right? And this was the platform that runs Google. Okay? And what they generously did was they published the architecture. Okay? More generous would have been for them to put all the code out there for all of us to have open source and just run their system, but they didn't do that. But they generously put out the architecture and said, you know, if we're having problems, other companies may, and we want to share what we did to solve the problem. So along came a guy by the name of Doug Cutting, and he said, you know, Google has the problem. I'm going to create an open source platform that makes it commercially available to use this same platform that Google is using today. So he's working on that, and he's going to keep it out in open source, and his 3-year-old son comes in with a little stuffed elephant, and he turns around and says, who's your friend? And he said, Hadoop. So Hadoop, as a platform, was named by a 3-year-old child, by a very brilliant man that developed that platform. Doug Cutting is a co-founder of Cloudera. And we'll talk about what Cloudera does, but I'd first like to talk more about that platform, that big data platform. We talked a little bit about it. Well, actually, let me point something out, too. Also, the thing interesting about the platform was it was going to run on commodity hardware, right? They didn't have a lot of money in the early days. So they said, we want to be able to take just Intel-based platform, string them all together. Disks are going to fail, but we want to be able to use cheap disks. So they built in all of this resiliency. It's self-healing. If a disk goes away, it doesn't create any alarms because it's smart enough to take the data that was there and replicate it in other places. It's also smart enough in the middle of running a deep analysis, if one node or one drive goes away, it just gets it somewhere else. So it's a very scalable platform. I don't know the numbers they have. Somebody else may know. It's tens of thousands of servers linked together, petabytes of data, very scalable, and it's linear scalability, right? So if you need to go twice as fast or you need to process twice as much information, you pretty much know how to get there, right? You can just expand your nodes, expand your drives, and it is massively parallel across that. So the pieces that we're going to talk about, Hadoop has something called HDFS. It's the Hadoop Distributed File System, similar to Google's GFS. It's just a file system. Okay? On top of that is an engine called a MapReduce engine. And that gives you the ability to transform, process, run analytics across all of this data that you have. And big data can be really looked at in two ways. Some ways it's just massive amounts of data. You're bringing in your web logs. You're storing, terabytes, petabytes of data. You don't really know what you want to do with it, but someday there's probably going to be some value in that data. Okay, so you're storing it in the file system. The other thing that it does really well, though, is that MapReduce engine can solve very complex analytics that you couldn't do in, say, a traditional query or relational database, because it allows you to run kind of advanced analytics across all of your data. Right? Not just sampling, not just this year's data, but 10 years worth of data, to look at patterns that you could never find when you start putting things into a database. Okay? So that's kind of the underlying piece. So you'll start hearing a lot about the product Hadoop. But I think it's also important to note that it's really made up of an ecosystem of products, right? Because Hadoop is the file system with this engine on top of it. But in order to bring that into an organization, you need a lot of other things to make it fit, right? You're going to be ingesting web logs. Well, how do you do that? Well, there's a project, an open source project, and all of this is free software. It's open source. There's a product called, Flume, to ingest log data, right? It's designed to do that, where you can bring that in off logs. There's other products called Scoop, which is SQL database into the Hadoop environment. So I want to be able to connect relational technologies to Hadoop and to be able to move data very quickly in between those. We're not going to talk about all these. One of them is called Hive, though. That's very important to people because it puts a SQL-like layer on top. So if you have a relational database person that can write SQL code, they can write code that will go against Hadoop. What Cloudera does for you is we take all these open source projects, we bring them together, we test them so that companies can commercially download those, again, for free, and know that all of these versions of the products are going to work together. Right? No reason to go out to the open source. There's no benefit in going out and pulling the products yourself anymore because we test it, we invest thousands of hours to make sure that it all works together. The other thing that's nice is that if you looked at this list 2 years ago, it would probably be half the products. New things are being brought forward to leverage this massively parallel platform, something like Mahout. It's a machine learning library. That wasn't there a year ago. But now it's commercially ready. We bring that into the CDH, which is Cloudera's distribution for Apache Hadoop. We test it, and we confirm that it works with all of these other products out there. So when you hear Hadoop, really think of it in a bigger ecosystem of products because Hadoop in itself is one piece, but it fits into an organization because of all of these other products that are integrated with the Hadoop platform. So a lot of people say, well, that's great. I can get rid of my real expensive database, and I'm just going to bring in Hadoop. And we don't really see it that way, right? We see that the technologies really coexist. Relational database technology is very mature. It's very good at what it does, but there is an upper limit for it. It can only store a certain amount of data. It gets expensive when you start going and storing lots of data over maybe a long period of time. So what we would suggest is that for those real-time reporting, for sub-second response time, for things that are highly indexed and multidimensional, leave it in the database. It needs to be there. But what Hadoop does is Hadoop gives you that ability to do a very inexpensive store of information. You can feed it into the database for the information that you need. And it also gives you that ability to run real deep analytics across tons of data. Okay? So they really are purpose fit, and you don't want to assume that, well, now I don't need to do this anymore. I'll just go with my free Hadoop platform and get rid of my database. I think most organizations realize there's a purpose for both of these. So how are companies using it? As you can see here, we kind of broke it down by the different verticals, and it shows different use cases that they would traditionally use. And there's two sides to this. Some of it's just data processing, right? I want to bring in lots of information, I want to format that information, and I want to prepare it for my reporting system. Okay? The other side is advanced analytics. That's going to be taking advantage of this massively parallel platform that's underlying all of this data. I think what you'll find is that some of the most common use cases have nothing to do with what vertical you're in, right? If you're a bank and you're bringing in tons of information, well, it's very expensive to store that on your mainframe, on an appliance type thing. So you keep year one there, and then you file everything off into a tape. Well, tape file systems are great, and they're cheap, but they're only cheap when you're writing out to them, right? When you have to go bring that data back, it becomes very expensive. You have the human capital costs. You have to put it somewhere. So a lot of companies are using this and using this commodity hardware to store tons of data. Store years 2 through 10, right? And the advantage of this over, say, a tape system is that information's not dead and locked up in a locker. I can actually run analytics and come in and say, well, here's the fees that we charged our customers 10 years ago, and here's what we're charging today. And we can show you the proof of that, right? So rather than have to go pull out the tapes and see what was happening, it gives you that ability to do a deep and cheap, say, storage of information and have it accessible very easy. Okay, so that's a very, very common use case. The other thing is when this unstructured information is being brought into the system, the transformation engine allows you to say, take that and put it in a usable form. So that engine can be used to make that information more valuable. Okay, because the other thing that is interesting about this is, again, we talked about, it doesn't care whether it's the structured data that your database can read or unstructured data. Right? You can run analysis across the whole platform. As we talked about, it's not necessarily a replacement technology for what you would have in an organization today. It's complementary. It may replace some more expensive things that you're doing, but from a platform perspective, we would see it more commonly to be the repository for all data, right, across however long back you need to keep that information. Bringing in logs, files, web data, relational database information, and then it feeds your operational systems that run your business and your reporting systems that are in your data warehouse, but it gives access to all information across any amount of time periods. So that's how we see it traditionally fitting in an organization. Did I race through that? So, I think the important thing there is we just race through a platform that has lots of deep technologies embedded in it. That's kind of a history and a high level of how it would historically fit in an organization. But it doesn't, it doesn't run without hardware. And, I think what Sunny's going to talk about in a little bit is a platform for optimally running this platform that's been out there and being able to scale to thousands of nodes, tens of petabytes of information, and feel comfortable that it's a 24 by 7 platform for you.